Hello, everyone. In this video, we will discuss derivatives of exponential functions. Derivatives of exponential functions. Natural exponential function. The derivative with respect to x of e raised to x is equal to e raised to x, where the base of natural logarithm e is an irrational number. General exponential function. The derivative with respect to x of a number b raised to x is equal to the natural logarithm of b times b raised to x, where the base b is positive and not equal to 1. Meanwhile, the general and natural exponential functions are related through the following equation. B raised to x is equal to e raised to the natural logarithm of b times x. Review. Properties of exponents. These properties can help in rewriting a function and simplifying its derivative. Examples. Find the derivative. Number 1. Y equals 2 times e raised to x. Solution. First, apply the constant multiple rule. And then, differentiate using the natural exponential function rule. Therefore, the derivative of y with respect to x is equal to 2 times e raised to x. Number 2. Y equals 6 raised to x all over 8. Solution. Apply the constant multiple rule. Then differentiate using the general exponential function rule. Thus, the derivative of y with respect to x is equal to the natural logarithm of 6 all over 8 times 6 raised to x. Number 3. F of t equals 3 times e raised to t minus 5 raised to t plus e raised to 3. Solution. Apply the constant multiple and sum or difference rules. And differentiate using exponential function rules. Note that the last term is just a constant, so its derivative is just 0. Hence, f prime of t equals 3 times e raised to t minus the natural logarithm of 5 times 5 raised to t. Number 4. F of x equals 4 raised to x times the quantity 1 plus x. Solution. Let us apply the product rule to express as simpler derivatives. Then differentiate using the general exponential function and basic differentiation rules. Therefore, f prime of x equals 4 raised x times the quantity 1 plus the natural logarithm of 4 times the quantity 1 plus x. Number 5. H of t equals 2 raised quantity t minus 1 all over e raised to t. Solution. First, Try h of t can be written in terms of a single base raised to an exponent. Use properties of exponents. The function now becomes 1/2 of 2 over e raised to t. Afterwards, take the derivative of h of t. Apply the constant multiple rule. Treat 2 over e as one base. Then differentiate using the general exponential function rule. Simplify the derivative using a property of logarithm. Thus, h prime of t equals the natural logarithm of 2 minus 1 times 2 raised to t all over 2 times e raised to t. Number 6. Y equals 7 raised to x times e raised to x. Solution. First, rewrite y as a single base. Use a property of exponent. Afterwards, take the derivative. Treat 7e as one base. Then differentiate using the general exponential function rule. Simplify the derivative using a property of logarithms. Hence, the derivative of y with respect to x equals 7e raised to x times the quantity 1 plus the natural logarithm of 7. Number 7. F of x equals 6 raised to 3x times e raised to quantity 3x plus 1. Solution. First, try to write f of x as a single base. Use properties of exponents. Afterwards, take the derivative of f. Apply the constant multiple rule, because e is just a constant with no variable exponent. However, the constant 6e raised to 3 has a variable exponent. Then differentiate using the general exponential function rule. Simplify using properties of logarithms. Thus, f prime of x equals 3e times the natural logarithm of 6 plus 1 times 6e raised to 3x. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.